Mobility and distributed systems present another challenge for time. If the time depends upon your location, then asking what time it is requires knowing where you are, or if you have multiple systems, where each one is. A lot of times you need to answer the question which event happened first, and if the two systems are in different locations or the two systems are moving, then it can be kind of difficult just looking at local date timestamps to figure out what happened. Beyond issues with time zones and things like that, there's also the issue of the international date line. Now, the idealized reference is it's a north-south line at exactly 180 degrees longitude, and when you cross it, the day changes. But the reality is a little more complicated because countries don't want the date line going through the middle of one of their main cities, for example. And in the Pacific Ocean, you can see the date line contorts quite a lot. For example, some of the islands that are moderately far east in the Pacific Ocean stay on the same date as Australia and Asia because it's said to make trade easier. Or more subtle but also problematic issue is that some software assumes that there's a maximum of 24 hours of difference between any two locations. But in fact, there's a part of the Pacific where there are two locations across the date line that are 25 hours apart. Some of the potential issues dealing with mobility and time zones are you have a system with multiple users in different time zones, and they have to agree what time something is and which event happened first. You may have a system that moves between time zones because it's mobile, and it may not even move all that far. It may go from one island to another and experience a 25-hour time jump. That move could happen while it's powered on, and it can deal with it, or it might happen when it's powered off, and it has to clean up the mess the next time the power turns on. Also ask yourself, what if the system is turned off during a daylight savings time change? Or even if it's on, there's a common bug that if you're setting the clock back an hour at daylight savings time, you see a bug where it sets it back an hour and then it goes forward and then it says, oh, it's time to set the clocks back, and it gets stuck in an infinite loop setting the clock back, or maybe sets it back twice. So those kind of things are tricky. They only happen once a year, and almost every daylight savings time change somewhere there's a report of some software that got it wrong. So that's something to pay attention to. A best practice for dealing with all this stuff is to keep time with Greenwich Mean Time, or UTC, inside your system. And that way, any two systems are comparing GMT times rather than local times. And that gets rid of all the local time mess for internal timekeeping. You then convert on the fly the GMT to local time if there's a need to display it. And at that point, you add in the effects of daylight savings time, time zones, etc. So that way, if a system's moving around, the internal timing isn't jerked around by which time zone it's in, but you do have to have local routines to be able to convert from GMT to local displayed time.